Hello scrappers and welcome back to my channel. So this would be episode 3 of me running this copper refining cell where I am refining the dirty copper that I got out of my waste bucket as a byproduct of getting the gold and silver out of IC chips. You know, in the first video I built this and got it up and running, and in the second video I ran it for not quite 2 weeks and checked on it from day to day. Had some interesting results. And in this third video, we're going to continue going. So this is day 13 on this thing. It's 24 hours after I put the new cathodes in. So it's time to look and see what's going on. Now, the voltage on the cell right now is very high, and it has just been climbing over time. Now, I was thinking that it was due to the cold, and it has been very cold. But things have warmed up a little bit this morning. So it's not so cold, but the voltage across the cell is still rising, which tells me that the resistance of the cell is rising. Now, I published part 2 of this series just this morning, and it's been very popular. Hundreds and hundreds of views already. Lots of good comments. One good comment got me thinking that maybe I've got stratification going on in the electrolyte in here. That could explain a couple of things. Let me turn the cell off and glove up, and we'll have a look at the anode. We'll have a look at the cathodes. Okay, got my gloves on. Now I came out early this morning and had a look at them because I had some things I had to do today. So I didn't have time to film, but I came out and had a look anyway. And I'll tell you what, there's a fair amount of copper on there already. But it's really thin at the top, and it gets thicker, 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 thicker towards the bottom. And there's a color variation too. It's very coppery at the top, and it's very dark at the bottom. And I hope that's showing up on the screen. Yeah. So we've actually plated out a fair amount of copper in only about 24 hours. Actually, not quite 24 hours. So let me look at another one of these cathodes. Same deal. Same deal. A lot of copper. Most of it's at the bottom, not so much at the top, and there's a color variation. So, somebody in one of my comments, sorry I don't remember your name, I'll go back and look and put it in the caption down here, said I might have a density variation or a density stratification in the liquid here, and that could be causing me the problems. Now, when I measured the specific gravity of the liquid the other day, I didn't stick the hose down very deep. I just got it at the surface. So let's wonder what will happen if I stick the hose way down. Oh yeah. Oh yeah, that is quite a bit more dense at the bottom. Okay. So we do have some stratification going on. If I get some from the top here. Oh yeah. So it's a difference between 0.12 and 0.125. So yeah, we've got some stratification going on. Now I don't have any way to circulate the liquid in here. So I think what I'm just going to have to do is I'm just going to have to stir it. And to do that, I'm probably going to have to take all the anodes and cathodes out. Just so I've got the ability to get in there and stir it somehow. So I think I will do that, and we'll take a good look at the anodes and cathodes after I get them out. Okay? Let me get started. Okay, I've taken the cell apart. Here's all the anodes, and they're looking, you know, a little the worse for wear. They're getting kind of eat up. This one's interesting. It's got areas on it that are, I don't know how to describe it, like islands that are left behind as the rest of the anode gets worn away. I don't know if there's areas of more or less pure copper, or I don't know, impurities or what. That's weird. You kind of have the copper color to them. They can't be too impure, I guess. Okay, but there's the anodes. Here's the cathodes. They're all looking pretty much the same. It's interesting how they've got vertical stripes in how the copper was deposited. I don't quite understand that unless it has something to do with how the metal was processed. I don't know. Left areas more susceptible to the growth of crystals, and I don't know. It's weird. But they're all very little copper at the top and a lot of copper at the bottom. And of course, it's not very nice copper. It's chunky, ugly, rough crystals because the voltage is way too high across the cell. So I'm hoping that stirring the cell and getting the liquid to a more uniform, specific gravity will help with this. And we'll get back to the way it worked in the beginning, maybe. We'll see. Okay. So let me give the cell a good stir. Got a little bit of floating copper in there that came off of the cathodes when I pulled them out. Some of that copper is not very well adhered to the cathodes at all. That also tells me the voltage is probably too high. So I'm hoping that giving it a good stir will get things redistributed good, and maybe the voltage will come down because the resistance. Now I'm going to stir up a lot of crud on the bottom of the cell. Oh yeah, there's a lot of black stuff in there. I guess in the next version of this, if I keep this up, I'm going to have to come up with some way to recirculate the liquid to prevent density gradients from forming. I'm probably going to let this stuff settle before I restart the cell. I may put it back together, or maybe not. Maybe I'll let it settle before I put it back together so all that crud doesn't settle on the cathodes. So yeah, there's a lot of black stuff down there. So that's the anode slimes I'm trying to create. So that's good. Well, let me give it a really good stir. I can see it's going to take a while to settle. I don't want to have to do it again. I'll give it a really good stir here. Hopefully we'll get rid of any density stratification. I feel chunky stuff on the bottom. I'll bet that's copper that's fallen off the cathodes. I'll definitely have to filter that out somehow when I go to process these anode slimes. Okay, let me let that settle. I'm going to clean the rails again, so hopefully we get a nice good electrical connection. In fact, I may take this opportunity to change the way I get the power to the rails. Yeah, this might be a good time to do that. Okay. I'll be back when this is cleared up and I've figured out a new way to get power to the rails. Okay. I think I've come up with a much better way of attaching the wires. I probably should have done this up front rather than using the alligator clips. So I've got a ring terminal there on the positive wire, and I've got it under the screw now that holds the cross member on there. So it's a good solid contact, at least for now. Things start corroding, we'll see. But it's a good solid contact for now. I've got the same thing going on over here on the negative wire. I probably should have done this up front, you know, rather than going with the alligator clips, because the alligator clips, they're steel, they're starting to rust, and yeah, that's not good. So I could wiggle them and I could see the voltage across the cell change, which was telling me that the resistance was changing, you know, at the points where the alligator clips were attaching. So hopefully this will do much better. Yeah, now we're just waiting for the anode slimes to settle back down to the bottom a little bit before I put it all back together and restart it. I just let me take some fresh density measurements after all that stirring. The anode slimes are still settling, so that may take a while longer, but let's get, squeeze the bulb a little more. Let's get a measurement at the surface. I don't know if you can read that. It's 1.250, right on the money. Okay, so that's at the surface. So let me stick this down as deep as I dare. And it is 1.250, right on the money. Okay, it would help if I held it in frame, wouldn't it? So anyway, that's good. So the stirring did good. It got it all uniform now. So we'll see how long it takes that density gradient to reform. I'll keep an eye on that, you know. I also, aside from fixing the wires, I also took some sandpaper to the rails. I took this whole thing out and worked on it. So I took some sandpaper to the rails, and they're nice and bright and shiny on top. So it's ready to go back together once the anode slimes settle a little bit and the water's not so black and opaque. It's starting to clear a little bit. If I quit stirring it up with the hygrometer, I think we'll be good pretty soon. So we'll just wait for that, and then we'll get this thing back together and restart it. Okay, still waiting for the anode slimes to settle, but just for funsies, let me turn this on with no load across it. So we're up to 2.86 volts. So the cell was putting a little bit of a load on it and drawing the voltage way down when it was even before I did anything to it. So hopefully when I put it back together, the cell resistance will be a lot lower than it was before. The current will be up, the voltage will be down, everything will be happy. We'll see. Okay, the cell is all back together. The liquid hasn't cleared, totally yet, but it's a lot clearer than it was after I stirred it. I've rearranged some things. I got the anodes that had the most meat on them left are in the middle now, because the middle ones seem to get eaten up the quickest, and the skinniest ones are now on the outside. Hopefully things will move along at a fairly even clip that way. So when I put the cathodes back in, again, I had some copper come off. You can see a little island of floating copper down there. So the copper is really not adhered to the cathodes all that well at all, which I am attributing to the earlier problem with the stratification, density stratification, and probably the high voltage this thing was running at. So I guess we're ready to restart and see what happens. Let me rearrange the camera and we'll see what happens. Okay, contact. Well, we're still up above a volt, but not much. So we've dropped by, what, over 1/3 of a volt anyway. That's good. And the current, well, that's back up some, because that was almost, had the needle pegged at the low end current-wise. So, okay. This is better. Not ideal by any stretch of the imagination, but certainly better. One thing I can try doing is moving things a little closer together now that the cathodes are not so freaking huge anymore. I can move everything a little bit closer together without too much fear of a short circuit, though I probably shouldn't be doing this with the power on, because I might cause a short circuit and blow that fuse. But I can move things closer together, and that's not having much of an effect at all. So I guess I'm just going to have to let it run as is and see what happens. As the cathodes get fatter, I will have to move things further apart again. But at least we've got the voltage down a lot lower than it was. We're not running up at 1.3 something volts, so that's good. And I still have hopes, because it's still, this liquid's pretty chilly. It's warmed up this afternoon, but again, it was in the 40s overnight, and this liquid still hasn't had a chance to warm up. In fact, the tub is sweating because it's so cold. The sun will be shining on it in a little bit, so it may warm up some this afternoon. I'll come out and check the voltage on it as it warms up. Hopefully the voltage across the cell will drop and the current through the cell will go up. We'll see. But definitely what I've done so far is an improvement. I'm just going to let it run and see what happens. Well, it's been, I guess, a little over an hour, and I think the cell warmed up a little bit in the heat of the afternoon. Unfortunately, the heat of the afternoon is over and the temperature is starting to drop, so it's probably all downhill from here. but the voltage did go down a little bit, so looks like the resistance of the cell dropped a little bit. Yeah, tomorrow is supposed to be a warmer day, so we'll see how the cell behaves tomorrow. It should be interesting. And I'll have to keep an eye on the stratification of the electrolyte in there. I was just reading the comments on part 2 of this, which I posted earlier today. And somebody suggested I put a fish tank bubbler in there. Not a bad idea. I am a little worried about keeping the anode slimes, suspended in the solution. I'm afraid they might get plated out on the cathodes. I don't know. I'm going to have to do a little reading on that. See just how they do circulate the liquid in these kinds of cells. But, yeah, that might be an idea. So I will look into that. Anyway, I guess we're just going to leave this overnight, and we'll see what we got tomorrow. Tomorrow will be day 14, exactly 2 weeks since I started this. Oh, and just a quick reminder to you that I have a second channel now called ElectroGeek64. I'll put a link to it either up in the upper right corner or in the description of the video. Check it out if you're at all interested in retro computing projects, electronic projects, anything like that. Because that's where all the videos that I make on those subjects go now rather than coming to this channel. So if you're coming here looking for the latest updates on what I'm doing with the Teletech System Master or with the ET3400 or any of my other projects, well, that's where you'll find them, ElectroGeek64. So thanks a lot. Check it out. Alright, so what is this? Day 14, I think? Day 14. So the voltage is a little bit higher than where it was yesterday, but not too bad. Well, I've been doing a lot of reading about running copper refining cells, and I've been doing a lot of reading of all of the comments and suggestions I got when I uploaded the last video, part 2, yesterday. And I really appreciate all those comments and suggestions. Thanks a lot, folks. That's really good stuff in there. Anyway, let's first off just have a look at things, see how things look. We pull out one of these cathodes. It's getting pretty heavy. So it's got quite a coating of copper on it. All right. This one too, quite heavy. Yeah, this one's quite heavy. Quite a thick layer of copper, surprisingly thick layer of copper on it, especially at the bottom. I'm starting to wonder if I'm getting stratified again. Yeah, quite a thick layer of copper. Again, especially at the bottom. Let's, I didn't get enough. So let's measure the specific gravity here. Yeah. Let me measure it down near the bottom. That was near the top. Yeah, so it definitely stratifies fairly quickly, because yesterday was when I stirred this. So I've been doing a little reading on how the big boys, the professional copper refiners, do things. They do circulate their liquid to prevent it from stratifying like this, but they circulate it very, very, very slowly so that the anode slimes don't get up in the water column and wind up plating out on the cathodes. So some of the ideas that I've seen in the comments sections, like a fish tank bubbler, not a bad idea, I suppose, but it's sure going to stir up the anode slimes. So, I'm not particularly worried about contaminating the copper on the cathodes, but I don't want to lock up the anode slimes back in the copper after I've liberated them from the anodes. That's the purpose of this whole process, is to liberate the anode slimes from the anodes so I can collect them And I don't want to do anything that's going to cause them to get entrained back in the cathodes. Then this whole thing will just be a waste of time. So, not sure how I can circulate this liquid without stirring up the anode slimes. I suppose, of course this is a plastic tub, so I was thinking if I put it on like a hot plate, low, and kept it warm and got some convection currents going on, that would keep it circulating gently. So, not sure what to do, but it looks like we're stratifying again already. I might have to give it a daily stir. That would be annoying. Alright, let me think about this. Alright, yeah, I was shocked to learn just how slowly the professional refiners recirculate their electrolyte. We're talking rates of inches a minute of liquid flow. So I don't know how I can do that with a pump or a bubbler or anything. But I've been over here playing around with this and I'm thinking, if I just shut the cell down, it's off right now, and I just do this maybe once a day or every 2 days or something, maybe I can mix the stuff up enough. I'm probably knocking stuff off with the cathodes. Yeah, I can see where it's banging against this other anode. I may have to take the, oh yeah, I may have to take cathodes out when I do that. Or do it more gently. So now, I can see I've stirred up some of the anode slimes off the bottom. So there's definitely some mixing going on there. Oh yeah, that's quite a bit more dense at the top than it was. Let me see what it is down at the bottom here. Yeah, pretty close to the same thing again. So that was pretty easy. I didn't have to take it all apart, although maybe I should have at least taken the cathodes out. I think I knocked some of the copper off of this one. But now it's all stirred up. The specific gravity is uniform again. Everything's spaced out right again because it all got kind of messed up. Okay, it's all back together. It's up and running. And the voltage has come down some, as you can see. So the stirring helped. The voltage is still pretty high. Like I said, I've been doing a lot of reading about how the professional copper refiners do it. And of course, their goal is to get really pure cathodic copper, which is not really my goal. But they do things differently. Not only do they circulate the fluid slowly, but they also run at much lower voltages, like below 0.3. Which, if I do that, the current is going to drop off to practically nothing, and this is going to take forever. And in fact, the professional copper refiners it does take a long time to run a batch of anodes through and get the cathodes out. It does take a long time. But yeah, I may be in a bit more of a hurry than that. I'm not so much concerned about getting quality copper at the cathodes as I am about getting the nasty anode slimes at the bottom of the tub so I can process them. So we'll run at this higher voltage and see how it looks. And I've been thinking a lot about why this density stratification happens in here. And it hit me last night why it's happening, at least my theory on why it's happening. I haven't seen a really good write-up on it, but it seems pretty obvious why it's happening, and I'll show you what I think. So we've got a density gradient forming pretty quickly in the cell, pretty much after only a day or so. You know, it's a lot less dense at the top and a lot more dense at the bottom. And I think what's happening is this. Around the anodes, we've got copper coming off into the liquid, and enriching the liquid in copper. That's going to make the liquid more dense. Dense liquid's going to sink. And over here at the cathodes, we've got the opposite thing going on. We've got copper plating out on the cathodes, and that's leaving the liquid around the cathodes depleted in copper. That's going to be less dense, and it's going to rise. So it's just, gravity doing what gravity does. The heavier liquids are going to sink to the bottom that are enriched in copper. The lighter liquids depleted in copper are going to rise to the top just because of the density difference. And over time, and apparently not very much time, we're going to wind up with this density gradient inside the cell. Unless I can figure out some way to circulate the liquid to cancel out the formation of the gradient. Or just stir it from time to time, which I've been doing. So I'm pretty sure that's what's happening. Well, it is day 16. We skipped day 15 because there really wasn't much new to report. The cell was just humming along pretty much as per normal. Day 16, though, I'm out here this morning. It's still early in the morning and things are still a little cool. I'm surprised to find the voltage across the cell so low. It's actually come down some overnight, which usually the opposite happens. It usually goes up overnight when it gets chilly. So I'm not sure what's going on here. Not complaining. Lower voltage, as far as I'm concerned, across the cell is good. So let's take a look inside and see what's going on. Okay, let's have a look here at the cathodes first. A fair amount of copper on there. Rough, grainy copper, but there's copper on it. Oh, here we're starting to get some dendritic growth around the top. Oh, and yeah, top and bottom on the back of this one. Interesting. Oh, yeah, see, I just accidentally touched the rail there. The copper is not very well consolidated. It came right off. Yeah, rough, lumpy. Oh, and lots of dendrites. Okay. Let's have a look at the anodes. Oh, look at that one. That is getting to be quite skinny. Not much meat left on it. Interesting. I don't know if that's showing up in the video or not. About how the crystal grains are being exposed as the thing dissolves. That's kind of neat. This one's got a lot of meat left on it. Some of these were not all uniform in size. Some of these ingots I cast were a little bigger than others. Oh, this one feels quite light. Yeah. I don't know what that plaque or whatever it is on there is. It's obviously something that's not dissolving away as quickly as the rest of the anode. It must be areas of, I don't know, impurity. Let me see if it comes off. It breaks right off. Whatever it is. I should set it aside because I should probably put it in with the anode slimes. I imagine if it's impurity, it's probably some of the stuff I want. Look, there's holes chewed clear through that anode. Huh. And then here's the last one again. It's getting pretty skinny. So, okay. Cool. In fact, I'm going to take these little bits and pieces I pulled off that anode and I'm going to throw them right in the cell so we keep them. Because they may be exactly the kind of stuff I'm looking for. Right, let me also clean my fingers a little bit here since I've got the black anode slimes all over them now. Get them back in here. Okay. Have a look at the specific gravity situation. 1.2, I don't know if that's showing up. I can't see the viewfinder. There we are. 1.250 from the top. We get from way down deep. 1.275. So yes, we have stratified again. But as I was expecting that, it's probably going to be a daily thing as the cell runs. So I need to stir it again. I may take the cathodes out just so I don't knock too much copper off of them. And I may have to space things out a little more since we're getting dendrites growing again. So let me give it a stir, space things out a little different, put it back together, and we'll restart it and see what goes on, okay? Okay, it's been given a stir, everything's put back together. Let's turn the power back on, see what it looks like. Oh, the voltage went up a bit. I did separate the anodes and cathodes by a bit because the growth of the dendrites on the cathodes. I just wanted to make sure they didn't actually grow over and touch the anodes. It's coming back down. Okay, I was thinking while I was putting it back together, I'm going to have a bit of a tough time when it comes to cleaning the anode slimes out of here because not only is there a lot of copper that's fallen off of the cathodes down in there, but of course there's also the that's not the one. I moved the anodes around a little bit so they would get chewed up a little more evenly. That's the one that's got the, I don't know what to call them, plaques or whatever on it. So they fall off too. They're going to get mixed in down there. Oh, here comes the voltage. Look at that. About like where I started this morning. They're going to get mixed in with all the other stuff on the anode slimes. So I don't know how I'm going to separate the copper out and keep the stuff I want if some of the stuff I want's in the form of lumps. That's a good question. I just hope I don't have to dissolve all the copper that's mixed in with the anode slimes down there in nitric acid, because that's going to be expensive. I'll figure something out. Okay. So we're just going to let it run, and well, it looks like we're getting close to the end. Some of those anodes are looking pretty darn eat up. Like I said, I have another set of anodes ready to go. I don't know if I'm going to run the cell with those in it or just clean it out and see what I got when these 4 anodes are pretty well chewed up, or at least mostly chewed up. They're all not, they're not all dissolving at the same rate. I've rearranged them. The ones in the middle seem to dissolve faster, so I put the ones with the most meat on them in the middle and the skinnier ones on the outside. Hopefully I can get them to whittle down at about the same rate. We'll see. But I got a feeling 1 or 2 of those anodes are going to get chewed up before the rest of them, and I'll probably have to call this experiment at that point. But on the whole, this is working pretty well. We're just going to let it run, see what it looks like tomorrow, or if some development warrants your attention before then. Alright, it is day 18. We skipped day 17 because I was super busy and there didn't seem to be too much of interest going on in the cell. In fact, it is the afternoon of day 18. Been really busy this weekend. We had an epic garage sale. I sold off better part of 3 dozen laptop computers that I picked up on a scrap run not too long ago. I'll put a link to that up in the upper right hand corner if you want to see the video of that scrap run. It was pretty epic. Alright, so let's have a look and see what's going on in here. The weather has whipsawed from hot to cold, as it will do in Florida in the wintertime. And we're back to being cold. So the cell's cold again. I haven't given it any attention in 2 days, so I'm sure it's stratified. So let's see what's going on here. Let me turn the power off before I screw something up. And I will move the camera and we'll have a look, because, oh, yeah, there's some interesting developments going on in here. Do you see the copper growth off of this cathode here? And you can't really see it on that cathode, but it's growing at the surface outwards. That's kind of weird. It's doing it on both sides of this cathode here. Yeah, see that? Both sides of the cathode. Now you can see that one over there. It's doing it too. It's growing out on the surface. Haven't seen that before. Oh, that is heavy. There's a lot of copper on there. Wow. Oh, yeah. Yeah, there's a lot of copper on there. Look at that. Holy cow. Okay. I'm afraid strange things might be happening a day unsupervised out here. Wow, look at that. Okay. Let's have a look at the anodes. Yeah, there's certainly not much meat left on that one. That's getting to be like a dagger point there. That one's a little more meat on it. Oh, that one, wow, look at that. There's almost nothing left there. Holy cow. And then this is the one with the weird plaques on it. It's still got some meat on it. All right. But I'm sure this is stratified. I don't even know if I have to test it, but maybe I will, just for funsies. We'll see what it is at the surface. Okay. Okay, something's wrong. That's not right. Okay, something's definitely wrong. Probably my hygrometer is messed up because this thing is pegging to the top, both at the top and at the surface and at the bottom. So that's not right. I don't know what's wrong with this thing. But I'm sure this is stratified. So I will take those funky cathodes out and give this thing a stir and put it back together. And probably, well, that's already in a good spot right on the end because the end ones tend to go slower. I'll leave that one on the end. And make sure the meatiest ones are in the middle, which pretty much they are. Okay. And then restart it. So let me get that going. Okay, I figured out what's wrong with my hydrometer. The little pin that the disc inside rides on is all rotted away, dissolved. So apparently this thing can stand up to sulfuric acid, but it can't stand up to copper nitrate. It destroyed it. Okay, good to know. But if I rebuild the cell so it uses copper sulfate and sulfuric acid, maybe this will work, at least for a while. We'll see. But yeah, this thing's toast. After got maybe 10 uses out of it, it's done. Great. All right, it's all back together. And we're up and running again. I think we're definitely getting close to the end game here. The one anode is really just about done. Another one not far behind it. I got two. I'm in the middle. That's got a little more meat on them, but I'm thinking about just stopping this thing after those two really eat up anodes are done, rather than running until the last two are done. Although, I don't know. We'll see. Maybe, you know. If the cell's behaving itself, the dendrites aren't growing too bad, maybe I will chew up the last of that copper. We'll see. And then I'll decide where to go from there. So the next few days should be pretty interesting because, like I said, I think we're getting close to the end. Okay, today is day 20. And in about the 30 seconds it's taken me to set up the camera, frame the shot, and focus everything, the voltage has gone from 0.96 down to 0.71, up to 0.86, and now back up to 0.96. So the voltage across the cell is, yeah, see, look at it. There, it's dropping. Interesting. I don't know if we got bubble issues again or what. I don't know. Anyway, let's take a look at what's going on in here. Day 20, again, skipped a day. Things are moving pretty slowly in here, and I've been pretty busy. So, let's see. Give you a look at what the anodes and cathodes look like. Not much left to that anode. Put it back here. That anode still has some meat on it, but not a lot. That one a little less, maybe. Oh, we turn the power off before I short something out. That one, kind of got some meat on it. Cathodes. Oh wow. A lot of growth there. It seems much more consolidated than it was early on. You know, it will knock off real easy. This stuff seems to be stuck on there pretty good. Yeah, in fact, I just banged it against the rail and nothing came off. So it's definitely sticking on there better. This middle one, wow, it has a lot of copper on it. Not so much in the dendrites, but a really thick layer of copper on it. Yeah, and this one, it's like the two outside cathodes have more dendrites, and the middle one, less dendrites and just a thicker growth. Interesting. So I'm going to do the usual thing. I'm going to give this thing a stir, because I'm pretty sure it's probably stratified. All of my hydrometer is toast, so I can't really test it for sure. So I'll give it a stir. Start it up again. I was not surprised to see the voltage up some, because, you know, I haven't given it any attention in a couple of days, and the anodes are getting pretty worn away. I'm sure the cell resistance is rising. And it's also cold again. So, yeah. It's sort of like a triple threat, you know. Smaller anodes, stratification, temperature dropping. So, yeah, that's a perfect recipe, it seems like, for higher cell resistance and higher voltage across the cell. Okay, let me get this stirred and get it up and running again, and let it go another day or two. Well, it's all stirred and back together. Unfortunately, the voltage is a little higher than it was. I'm not sure why. I even tried cleaning the rails, so I'm not sure why the voltage has gone up. But of course, it's been all over the place in the last little while. That on there. Oh, and I'll show you this too. Every time I take the cathodes out to stir the bath there, some of their dendritic copper falls off. So I'm saving it so we can get a more accurate weight on just how much copper we've transferred over to the cathodes. It's not going to be a totally accurate weight because I know there's a lot of copper that's made its way down to the bottom of the cell. I can feel it down there when I stir. So an approximate weight is what we'll get. Okay, so just going to let this run, and we'll look at it again in a while. All right, it is the afternoon of day 20. Day 20, and I'll tell you what, we are getting close to the end here. We are really getting close. The voltage is coming up, and I'm not the least bit surprised because, number one, it got really, really cold again last night. In fact, it's been cold the last couple of days. Yesterday was freezing cold and rainy all day long. I hardly even got out here. I just came out to give a quick look at it and then hightailed it back into the house. Today it's just freezing cold, but we've also got almost no anodes left. So I'll give you a quick look at the anodes. There is really not much left. This one back here, there's barely any of it down in the electrolyte. This one here, still pretty long, but awfully, awfully skinny. There's not much metal left on that at all. This one here, this one's got some meat to it. It's gotten a lot shorter, but it's kind of fat. So that one's probably got the most meat on it. And this one here, long, very skinny, very sharp. And, you know, another day or two, and I think these will be done. I really do. I have decided I'm just going to run it until the end. Might as well just run it until there's nothing of the anodes left in the liquid. I'll take the little stubs and melt them down and make new anodes in the future. Although I'm not sure that the stubs, there'll be enough of the stubs to make even one anode out of all four of them. So I'll just let it run. Quick look at the cathodes here, although tough to get them out between the rails. I have to turn them diagonal because they got so much growth on them. So, but they're not going to grow much more because there's really not much material left on the anodes. So I think, like I said, I'm just going to let this run until it's done, which should be in another day or so. And then we can move on to getting the anode slimes out of this and see what I can do with them. I don't think I'll run the next set of anodes. I'm kind of eager to see what is going on down on the bottom of the tank and figure out how to process that material down there. So I don't think I will run the next set of anodes right now. Day 20, we're just going to let it run. And probably I will be back when the anodes are gone. Okay guys, it is day 25 and we have finally reached the end of this experiment. As you can see by the voltage over here, it's pretty darn high. I've actually been turning the voltage down a little bit each of the last few days just to try and keep us below the threshold where electrolysis would start, because I didn't want to waste a lot of power on electrolysis. I also didn't want to fill the tub up with a mixture of hydrogen and oxygen gases because they're explosive. But the voltage is just going through the roof, and I know what the reason is. The anodes are gone. I looked at this yesterday briefly, and there was basically just one anode left that had any length at all in the liquid. And come out here this morning, and I will be willing to bet dollars to donuts the anodes are gone, just because the voltage is popping up like this. Let me turn the power off, and we'll take a quick look at the anodes, or what's left of them. Well, there's one, or what used to be an anode. Okay. Okay, this one here has just a little tiny nub left on it that's barely touching the water. Okay. That's the one that it still had some length on it yesterday. That one, gone. This one, gone. Okay. So we got all the anodes pretty much gone. I'm going to call it at this point. There's no point in trying to run this to the bitter end. We'll just shut it down here. Have a look at the cathodes. Wow. Look at that growth on there. That's a lot of copper on there. That's heavy. That is heavy. I hope that's showing up. Suppose I could zoom in a little bit, huh? Yeah. That's a lot of dendritic growth. You know, the next time I do this, I'm going to clean the plates really well before they go in, just so hopefully I get more even growth on them. Because I'm thinking, let me get these eat-up anodes out of the way, because they're not doing anything anymore. They're just in the way. Let's look at another cathode. Yeah, pretty much the same thing. It's weird. Maybe I'll move the camera over here and give you a look at them from the top here in a second. It's weird how they grew out along the surface of the water. I don't know if that's showing up how flat it is across the top. They grew out along the surface of the water, outwards. There, you see how that cathode grew out along the surface, and this cathode did too, but you gotta kind of look at it from this angle here. Very interesting, very interesting. All right, let me get the cathodes out of here, and we'll weigh them up and see how much copper we've got on them, and we'll weigh up what's left of the anodes too. We're being scientific about this, remember? So, got to get some numbers. Okay, let's get a weight here on what's left of the anodes. Alright. Not much is left of the anodes, that's for sure. So, it looks like about 210 grams is all that's left of these anodes. We started out with what? Oh, I don't remember. I'll have to consult my notes. I better not spout off the top of my head because I'm always wrong when I do that. Then let's weigh up these cathodes. 842 grams. And I think from this angle, you can see how stuff grew out along the surface of the water. That's kind of neat. So we got 842 grams in these cathodes, minus whatever they weighed initially, which wasn't too much. It was like 50-something grams. Plus all the weight of the previous set of cathodes, minus what they weighed initially. I'll have to do some figuring. Some Jethro Bodine type ciphering I'll have to do. And we'll figure out just how much copper we accumulated. And I'm pretty sure the copper we accumulated is going to be more than the weight of the anodes was originally. I think we have depleted some copper out of my really highly saturated solution of copper nitrate. I think we got some copper out of that. But, you know, I need to do some figuring first to be sure. So I will do that. I'll get back to you when I got some numbers here. Alrighty, I've spent the last 20 minutes reviewing my notes, reviewing the video, and making some more notes. So we can figure some stuff out now. So here's the anodes. We'll start with these first. So the original, ooh, dirty. Bottom of this plate's dirty. Rats. Messed up my notes. They were, in spite of my poor handwriting, fairly neat. Oh well. So the anodes started out at 1,868 grams, 1.868 kilograms. They ended at 214 grams. I don't know if any of that's showing up on the viewfinder. Yeah. So they had a loss of 1,654 grams of copper. So these got lighter by 1,654 grams. Now if I look at the first set of cathodes, which are in this bag right here, the first set of cathodes, they started out at 154 grams. They ended at 1,172 grams, so they gained 1,018 grams in copper. So they gained over a kilogram, a little bit of over a kilogram. Then we got the second set of cathodes, and they started out at 52 grams. They ended at 842 grams for a gain of 790 grams. So the total amount of copper we gained was 1,808 grams. So as you can see, about 154 grams of extra copper came from the electrolyte. Yeah, I was thinking there was too much copper here. So yeah, so apparently I need to get a new working hydrometer and find out what the specific gravity of the electrolyte is now. I'll give it a good stir and find out what the specific gravity of the electrolyte is now, because I'll know in the future if I make it stronger than that, the system's just going to steal copper from it until it gets down to that level. So there's no point in making it more concentrated than that. So, okay, so we got 1,808 grams of fairly clean copper between the two sets of cathodes over here. Although these first set of cathodes have been sitting around for a while, they've darkened up and started to turn green. But still, there's a lot of clean copper in there. And I got these over here. And, you know what came in the mail yesterday? Finally. A nice cast iron ingot mold. I think the copper from this first electrolytic refining will be the first victim to go into this ingot mold. I think I'll melt down this copper and make myself a nice copper bar out of it as a keepsake, a memento. Okay, so here's the numbers on the amount of copper we moved. Now, there's always going to be somebody in the comments, any video I do, who says, you got to calculate your electricity costs. The electricity's killing you. It's way too much electricity being used. You should put in solar panels and get your electricity for free. Okay. There's always somebody. So I did a little figuring on that too. And these are kind of rough numbers. I don't have exact numbers because the current was all over the place. The voltage was all over the place. So I'm just kind of figuring averages. All right. So 25 days at roughly 2 amps. Sometimes it was more, sometimes it was less. We'll call it 2 amps. And 1 volt. Sometimes it was more, sometimes it was less. We'll call it 1 volt. Okay? So that's 1,200 watt hours of power. times 2, because I figure my power supply is only 50% efficient at best. So that means 2,400 watt hours of power were used, okay, or 1.4 kilowatt hours of power. Now my electricity cost is 13.17 cents per kilowatt hour. So I burned up a grand total of about 31.61 cents of electricity to do this experiment. Yeah, I could spend a few thousand to put in solar panels and get my 31 cents worth of electricity for free, but I'm not sure that's the most economical way to do it. Okay? So this experiment really didn't cost me much. I mean, the copper that I made the anodes from was a waste product out of my waste stream. You know, I used some wire I had sitting around to make the first set of cathodes. I had to actually buy the copper foil to make the second set of cathodes, but that was fairly inexpensive. I think I bought the tub. I 3D printed some stuff, and yeah, I'm looking back over my shoulder at the equipment over there. I 3D printed some stuff. I had to buy a couple bricks. They're like, I don't know, 2 for 99 cents at Lowe's. Let's see, I had the stainless steel rails already. I had the wire. I had the Heathkit battery eliminator. Let me give you a look at all this stuff. I'm just, you know, refresh your memory of what all this stuff is here over here, okay? So, yeah. So I had everything inside the tub already except the bricks and the stuff I 3D printed. I had the steel rails, I had the wire. I had to buy the tub, but I actually bought this tub about a year ago for something else. And then I didn't need it anymore, so I guess we'll call that free. I had the battery eliminator already. I had the Variac already. I had the nice Centec multimeter already. Use it a lot for things, you know. So this experiment did not cost me very much at all. You know, the copper nitrate solution I was using, again, another free byproduct of my getting gold out of IC chips. So really, I have not spent much on this project at all. So hopefully, there's some gold and maybe other precious metals down in the bottom of this tub. I don't know if there'll be enough to reimburse what costs I have, but hey, it's an interesting experiment anyway. So next up, I need to get at the stuff in the bottom of this tub, and I can see there's a layer of stuff there. I don't know if it's showing up on the camera. Yeah, maybe it is. There's a layer of stuff here. I'm sure there's a lot of copper contaminating it, and I'll probably have to figure out a way around that. But yeah, so I need to get the anode slimes out of here. I also, what I will probably do is I think I will just siphon off this liquid and probably filter it and set it aside, because I can probably just use it again. You know, I got another set of anodes ready to go, but I think I'm ready to try and get some of these anode slimes and see what's going on with them and see if I can extract anything good from them. Alright, so I think we did pretty good over the last 25 days, and we got some good numbers on electricity usage and on how much copper we moved. Got an idea on electrolyte concentration, what works, what doesn't, what's too high. Learned about stratification and the need to stir or circulate the liquid. So, hey, that's a lot to pack into one video. So, I think that we will leave it here and pick up in the next video with me processing what's in the bottom of this tub. Figuring out how to process it anyway. I got to make it up as I go along. Never done this before. Not on this scale anyway. So, okay, we will pick up there, and thanks for watching. If you've been sticking it out this far, I really appreciate it. Subscribe to see the future videos in this series and lots of other videos I got coming out. And remember, I have a second channel, ElectroGeek64. Check that one out. And press subscribe on both channels to be notified when new videos come out, and push the little bell icon YouTube makes you push to be notified when those new videos come out. And thanks again for watching. I'll see you in the next video.